Alright, welcome back everyone. Yesterday we talked about uniform distribution. Sorry, I'm trying to find a paper here. So your warm-up is to tell me what is uniform distribution. Okay, so today we're going to talk about non-uniform distribution. So non-uniform distribution means that the outcomes do not all have the same probability, okay? And here's our first example. So Mrs. Hemmingson has a bunch of colored pencils, 3 yellow, 6 orange, 2 green, and 4 brown. She randomly chooses a color to give to a student. To find the sample space, so that's going to be 3 yellows. I don't want to have to write yellow over and over again. 6 oranges. Okay, 2 greens. And a brown, and 4 browns, I'm sorry. Okay, so that's our sample space. Those are all the possible outcomes I could have. So what is the probability of choosing a brown pencil? Well, I have 4 brown pencils. I don't know if you guys can see this. Hopefully you can. I have 4 brown pencils. I'm writing this in purple. Out of however many total pencils I have. So 3, 9, 11, 9, 10, 11, 12, 13, 14, 15 out of 15. So there's 4 out of 15 chance. And if you would like to know the percentage on that, that is 26.7%. Okay. Now it wants me to construct a probability model, which we did yesterday. So since I have multiple of each color, I'm just going to write one of the colors down. So yellow, green, oh, I skipped one, sorry, orange, and brown. It doesn't really matter what order you put these in. Now I already found the probability of getting a brown pencil, which is 4 out of 15. The probability of getting an orange one is 6 out of 15, which I can reduce. I can divide top and bottom by 3, so that gives me 2/3. Or, I'm sorry, 2/5, I apologize. 15 divided by 3 is 5, not 3. 2/5. Green has a 2 in 15 chance of coming up. And yellow has a 3 out of 15 chance, which is going to be 1/5. Okay? 15 here. So that's all I had to do for my probability model, is sit there and calculate all of them out. So this would be more of an experimental probability because they're giving you this, okay? Alright, so next example. A number cube was incorrectly made. The number 1 now has a 1 in 4th chance of appearing instead of a 1 in 6th. Everything else has an equal chance of occurring after that. So remember, all probabilities must add up to 1. So I know here, I'm kind of going to skip around a little bit. Probability of a 1 occurring is 1/4, right? Okay, and if I want to find the probability of rolling a 4, 1 minus 1/4, which I'm actually going to write as a decimal, 0.25, because decimals are going to make my life just a little bit easier in this problem. 1 minus 0.25 is 0.75. Okay? And I have 5 other numbers, and they tell me the other 5 numbers are equally distributed. So I'm going to do 0.75 divided by 5, which is going to be 0.15. So that means every other number has a 0.15 chance of being selected. So the probability of rolling a 4 is 15%, or 0.15, whichever you would prefer to write. And then when I construct the probability model, all the rest of these numbers are going to be 0.15, over and over and over again. Okay? So 1 has a chance, 1/4 chance of happening. 2 through 6 have 0.15 chance of happening. So if you want this as a decimal to kind of see how much bigger that is. Okay? So if you were trying to roll a 1 in one of those probability activities we did, this would be a good die to have. Okay. Alright. So it says the data below shows the heights in inches of 20 players of a junior baseball team. Okay? So we want to group the heights into 4 intervals. So I want between 55 and 60. So no, 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 nope, nope. This one here. So that's one. Oh, and this guy here, I missed him. Between 55 and 60. It's 55 and 60. Alright, so that gives me 1, 2, 3, 4, 5. So 5 numbers. This is kind of like the fish problem we did the other day. Okay, between 60 and 65. So I'm going to get 60, 61, 64, 64 again, 62, 60 and 1/4, 63. So it's 1, 2, 3, 4, 5, 6 numbers here. Okay, so between 65 and 70, so those 66s, 68, 68 and a half, basically everything without a 7 in it. So that's 1, 2, 3, 4, 5. And that leaves me with 2 extra ones left over. Or I'm sorry, 3, because there's 1, 2, 3 left over because these ones are all crossed off already. Okay? And I'm going to count these, so that's 10, 16, 17, 18, 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, I missed one. So 70s are 1, 2, 3. I think that's all the 70s we had. So 70s is right. 65. I circled all of them. So 1, 2, 3, 4, 5. Okay, 6s. 1, 2, 3, 4, 5, 6, 7. Oh, this is the one pink. So this is why if you double check yourself, you won't get messed up on the test. So just so you know, the highest number in the interval is not included in the interval. So 55 to 60 is really 50 to 59.9, but we write to 60, just so you know. All right, find the relative frequency of each interval. Well, I just counted them all, and I know it's 20. So 5 divided by 20 is 0.25. So a quarter of them are between 50 to 60 inches. 7 divided by 20 is going to give me 0.35, or 35% if you'd rather. And we already did 5, which is 0.25, and 3 divided by 20, which is going to give me 0.15. Okay? And represent the probabilities using a histogram. So I like percentages myself, so 25%, 35%, 25% again, and 15%. So I'm going to draw a histogram. Remember, histograms are intervals of information, so I'm going to skip a little bit here. 55, 60, 65, 70, 75. And then 10, 20, 30, 40. Okay. So 55 to 60 goes to the nice 25 here. 60 to 65 goes to the nice 35, so a little bit higher here. Back down to 25 again. And then 15, so that goes about right here. So that was my wonderful probability histogram. Okay. And I could write, 25% in each one, or 35%. So that way you could see better which percent each one was, because sometimes those lines are hard to read. So your exit slip, what is the probability of getting someone who is taller than 65 inches? So taller than 65 inches is going to be these cute little blocks. Okay, so what is that probability? Oops, sorry, you guys can't see that box. There you go. Okay, have a wonderful day. Make sure you turn in your notes. We'll talk to you tomorrow. Bye-bye.